All right, example 4. Now, I'll be honest with you. This question is quite advanced at this. So I think I'm going to hold off on this one until we see, because the region exam likelihood of something like this is extreme. But this question would require you to use some trig in order to find this. So basic concept would just be like if I was to drop an altitude here, right? We know that that would make it 90 degrees. And if it's an altitude of an isosceles triangle, then we've got two angles being divided here, so you get 20 and 20. And it also would split this up so that that point at altitude would intersect at the circle's center. So, like I said, there's a lot of trig that would be involved here. I would need to use the sine of 20 to find the radius here. I'd have to use cosine of 20 to come up with what the altitude was itself. Once I had those two values, I could find the area of the circle. I could also find the area of the semicircle. And then at that point, it's an easy concept. It's just simply area is just going to be the area of the triangle plus the area of the semicircle. So in respect to the process, it's an easy concept. It's just that to get the numbers, it's involved. You got to use the trig here. So I don't want to waste our time because, like I said, the Regents exam is not going to have something this extreme to it. But again, if you want to challenge yourself, by all means, go for it. And if you do want to give yourself a challenge, I will tell you that the answer would be approximately 37.5 units squared. So feel free to give yourself a chance to try that one. But like I said, it's sine of 20, utilize that to find this side, cosine of 20 to find the red side, and then plug it into the formulas. All right, looking at the next example. This is area of a sector. So area of a sector, like, is basically just a portion of the circle, a sector, a section, or a portion. So we really just need to know, utilize our area formula, which we know is area equals pi r squared. So in this example, the radius is 10, right? They gave it to us here in the picture as well. So I got pi times 10 squared. So we know that that's 100 pi, right? And if they wanted a decimal answer, they could. But in this case, in terms of pi, it's fine. So what if I said to you half of that circle, right? I know all of you are smart. You would just take that number and simply divide it in half. Well, then the area equals 1/2 pi r squared, right? Or simply divide it by 2. So that would be 1/2 of whatever the area was, which we already found out to be 100 pi. So now we know my answer is just 50 pi. And if I said a quarter of a circle, right? Well, that's area would be 1/4 the area of the circle. So again, that would be 1/4 of what we already know to be 100 pi from there. For some reason, it's getting a little sloppy here. 100 pi. So it's just simply a concept of just taking what you know and just multiplying by the fractional part here. So this would be 25 pi, right? So if that's the case, then what happens when I have something that says defined by a central angle of 60 degrees? So now they're saying here, if I look at the picture, what happens if I don't come out with a half or a quarter? What if I specifically come an amount of 60 degrees? How much is this? How much is this section here, right? Again, it's just the same like we did here with the fact that I've got, a portion or a fraction of the amount. Same thing here. What fraction of that is the whole? Well, in a circle, the whole circle is how many degrees? It's 360 degrees. So I simply take the 60, divide by 360, right? That is our fractional amount. And then, just like all the other ones, we're going to just multiply that by whatever the area was. And the area of the whole thing was 100 pi. So in this problem, we now have this coming out. And 60 out of 360 is just a sixth. So now it's a sixth of 100 pi. And a sixth of 100 pi would be 100 pi divided by 6. Which I can simplify because 2 goes into both of them. So that would be 50 pi over 3. So that would be the value. Again, I could find the decimal equivalent of that and round it off if I needed to, but that's your area in terms of pi. So really, what did we do there? What happens if I start changing it and changing this degree? So we can create a little formula here. So jot this down. All right, we can have here. So the area of a sector is simply just going to be the arc degree, or the angle degree, whichever way you want to describe it, it's the same thing, over 360 times the area of a circle, which is pi r squared. So that's all our formula is. So that fraction here, and again, it works with a quarter, works with a half, right? Whatever the angle is, like let's say it was 90 degrees, right? 90 out of 360 is 1/4, aka a quarter of a circle. Or as I say half, well, half of a circle is 180 degrees. So 360 and 180 over 360 is just a half. So whatever that amount is, whatever that angle or that degree is, we just simply divide it by 360. That gives us the fraction of the circle we're talking about. And we simply multiply that by the whole thing, and it tells us what that portion is. So if you look at example 6, we're going to utilize the area of a sector, but they made this even a little bit more because now it's not just the whole sector, which would be this part here. That's the sector, right? The wedge, so to speak. But now it's just the blue part. What's that portion alone? So this is like the area of a shaded region part along with area of a sector. So the area of the shaded is going to equal, in this case, the area of, I'm going to just write sector here, minus, right, the area of a triangle, right? So if I remove this green triangle here, that would just leave me the blue part. So let's actually solve that. So area of the sector is going to equal, we know that the angle is 90 degrees. Now again, they could give it to us here, or they might write it out here like this and say the arc is 90 degrees. It's the same thing. So we're going to say 90 out of 360 times pi r squared. So pi, and the r in this case is 5 squared. So 90 out of 360 is just a quarter times 25 pi. So that, again, I could get a decimal, but for now let's just leave it in terms of pi. So that's just 25 pi over 4. So I'm just going to keep that here for now until I actually plug it into the calculator. And we got to find the area of the triangle here, which, again, this is a radius of 5, and this is also a radius. So again, anytime you have a radius in a circle, that has to be the same. So this is also going to be 5. So 1/2 base times height is going to be 5 times 5. So 1/2 of 25 is 12.5. So now I'm subtracting 12.5 from that answer. So now that I have all the information, now I'm going to go back and actually plug that into the calculator. So 25 pi, and if I divide that by 4, that's going to get me a decimal of 19. Let me do it and keep it the colors consistent. That's going to be 19.634954 blah 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 blah. I'm going to subtract the 12.5 from that. When I do that, I get an answer of 7.13495 blah 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 blah. It tells me to round to 1 decimal point, so that's approximately 7.1. Again, no unit measure, so just units squared. So, like I said, it's now we're just kind of putting everything together here. We've got the ability to, solve those missing this shaded region by just doing the section or the sector of it, and allowing us to, just remove the portion that we don't need to find that area. The other thing is, and we'll see other examples like this. This is referred to as the minor arc. I could also be describing something to you like with all of this. This would be the other portion, or the major arc, which is the same thing as this degree. So the what's left over, like what's the remaining part of the 360 in this example would be like 270. So if they wanted maybe like this section, you could, but they told you this angle, you could say, the other part of that is 270, just 360 minus 90, which gets me the 270. So you can sometimes see things like that that'll also, require you just maybe an extra step to find the degree or the angle. So, but take the opportunity and try these on your own, and if you will work on them, and then give some practice problems to try it on your own.